Solve 5 raised to power x minus 3 raised to power x equals 16. We have 5 raised to power x minus 3 raised to power x equals 16. Let x equals to 2a. We are replacing the given power with another power. So that is, we have 5 raised to power 2a minus 3 raised to power 2a equals to 16. Now, the next step is that this can be written using law of indices. We have 5 raised to power a raised to power 2 minus 3 raised to power a raised to power 2 equals 16. Now, 16 can be written so as product of two factors. Now, let m, we are going to write this as product of two factors too. Let m equals to 5 raised to power a, and also n equals to 3 raised to power a. That means wherever you see 5 raised to power a, you are going to put m there. We have m square, and whenever you see 3 raised to power a, you put n there, minus n square equals to 16. So this can be factorized using difference of two squares method. We have m plus n, then multiplied by m minus n equals to 16. This is an example of the Diophantine equation. So that is, when you are given one equation with two variables, so it is said to be the Diophantine equation. We are going to apply knowledge of solving the Diophantine equation in solving this. Now, this has been written as product of two variables. I mean, the left hand side, we are going to write this as product of two variables too. So that is, we have m plus n, then multiplied by m minus n equals to 16, can be written as 2 times 8. Then we can write as 1 by 16, and we can also write as 4 by 4. So now, but here, so for us to be having 16 is an even number. That means for 16 to be an even number, and if you have multiplied two numbers together to give us even number, one of the numbers must be even, or either one of the numbers is even, or both numbers are even numbers. So in this case now, so but because of the nature of the number we are given, which is 16, now we are going to take m plus n. M plus n must take higher value out of the two factors. So it must take the greater, while m minus n will take the smaller. So therefore, this is out of it. Now we have 1 times 16. This can never be the factors because of the nature of the factors that we are having here. So therefore, we are going to use 2 by 8. So that is, we have m plus n, then multiplied by m minus n equals to 2 multiplied by 8. So now m plus n, so the result, because m and n must be even number, so therefore m and n must also be positive integer. So as a result, m plus n will be greater than m minus n. So therefore, m plus n will be equals to 8. Then m minus n equals to 2. Label this one as equation 1 and this one as equation 2. Now, adding together, m plus m will give us 2m. Then this cancel this. 8 plus 2 will give us 10. Divide through by 2 by 2. It implies that m equals to 5. So we have m to be 5. Now, solving for n. So we have m minus n equals to 2. So m is said to be 5. Substitute 5. So we have 5 minus n equals to 2, implies that minus n equals to 2 minus 5, which implies minus n equals to minus 3, n equals to 3. So therefore, we have gotten m to be 5 and n to be 3. So back to what we are giving, what the solution we use here, that is m equals to 5 raised to power a. It implies that 5 equals to 5 raised to power a, which implies a equals to 1. And also, we are to use n to be 3. So 3 raised to power n equals to 3 raised to power a, which implies 3 equals to 3 raised to power a. It implies that a equals to 1. Because 5 can be written as 5 raised to power 1, and 3 can also be written as 3 raised to power 1, which implies a equals to 1. And we have s to be 2a. Then s equals to 2a. Substitute 1 for a. That will be 2 times 1. We have 2. So therefore, s is said to be 2. With the knowledge of the Diophantine equation, then we got s to be 2 in this equation.